All right, I just wanted to get on here and record a couple extra examples. This one actually comes from the lecture, so if you guys are in my online class and you watch the lecture, you've already seen this. But for my Zoom classes, you haven't seen this one, and then I wanted to do some additional examples as well. So this example says if h of x equals x squared minus 3 over x times f of x, and f of negative 2 equals 3, and f prime of negative 2 equals 1/2, then find h prime of x. So let me just real quickly remind you the product rule. The product rule says if f times g, and I want the derivative of that, is the derivative of the first times the second plus the first times the derivative of the second. And then if I have f over g, it is the same in the numerator except for a minus sign, f prime g minus f g prime over g squared. Okay, so I want to take the derivative of h. So I want to take the derivative of the top. So the derivative of the top is going to be 2x times the bottom, x f of x, minus the top, x squared minus 3, times the derivative of the bottom. Now the bottom is a product. So I have the derivative of the first, which is 1, times the second, just f of x, plus the first times the derivative of the second, f prime of x, all over the denominator squared. All right, now we could simplify this and make it a lot prettier, but I know that I'm going to have to plug in -2. So I'm going to go ahead and plug in -2 and then go in and plug in what f of -2 is and f prime of -2. And it may be easier to just simplify the numbers rather than simplifying the algebra. So here we go. So I have 2 times x, which is -2. And then I have -2 f of -2 minus -2 squared minus 3. Have 1 times f of x. Let's just write it as f of -3 plus -2 f prime of -2 all over -2 f of -2 squared. All right, so now let's try to clean it up a little bit. So I have 2 times -2, which is -4. I have a -2 times f of -2. F of -2 is 3. So I have a 3 here. Minus, I have -2 squared, which is 4, minus 3. So that's just 1. Let me just erase that. That's just a 1. Then I have f of -3, which again is -2, minus 2 times f prime of -2. F prime of -2 is 1/2. All right, all over -2 f of -2, which is 3 squared. All right, so what do we have here? I have a -4. -2 times 3 is -6. I have 2 times 1/2, which is 1. So I have a -2 minus 1. And what do I have here in the denominator? -2 times 3, which is -6, but that is squared. So we're getting closer. I have a -4, -6 minus -3. So that's a +3 all over 36. She's really testing my arithmetic here. -4 times a -3 over 36. And that's what, 12 over 36? 1/3? 1/3? 1/3. All right. Hopefully my arithmetic's right. My calculus, I'm pretty sure is right. My arithmetic, maybe not. All right, so we had to use the quotient rule. We also had to use the product rule. All right, let's try a similar example. Where is it? All right, here they are, right here. Let's see if I can turn it this way so we can see it better. All right, so it's something similar. They give us f of 2, they give us g of 2, they give us f prime of 2, g prime of 2, and they want us to find h prime of 2. And right, they give us several different versions of h. Why don't we do A and D? All right, so, well, I guess h isn't so bad. So h prime of x is just going to be 5f prime of x plus 2g prime of x. If I want to find h prime of 2, then I'm just going to have f, or 5 times f prime of 2 plus 2 times g prime of 2. And then I'm just going to plug in my numbers. So f prime of 2 is -2. So 5 times -2 plus 2 times g prime of 2, which is 4. So I have a -10 plus 8. So I think we get -2. All right, so that one wasn't quite so bad. And now let's go ahead and try D. All right, so we're going to have to use the quotient rule on this one. So h prime of x, we're going to take the derivative of the top, which is g prime of x, times the bottom, which is 1 plus f of x, minus the top times the derivative of the bottom. Well, the derivative of 1 is just 0, so I'm just going to get f prime of x divided by the denominator squared. 1 plus f of x squared. All right, but we want to find h prime of 2, so now I'm just going to plug in 2 everywhere I see an x. So h prime of 2 is going to be, hey Tiny, g prime of 2, 1 plus f of 2 minus g of 2, f prime of 2 over 1 plus f of 2 squared. All right, I'm just going to move that up. All right, so g prime of 2 is 4. 1 plus f of 2 is 3 minus g of 2 is 2, f prime of 2, and negative 2. 1 plus f of 2 squared. Let's move it up one more time. So I have 4 times 4, which is 16, minus a negative 4, so plus 4, over 4 squared, which is 16. So I get a 20 over 16 divided by 4, so 5 over 4. All right, so I think you had a couple of your homework questions that are like this. It might show up on your next exam, so I wanted to do a couple more like this. All right, the next ones that I wanted to show you that I've noticed some people have struggled with are the graphing of the derivatives. So the first page is just matching, but I kind of wanted to go through maybe one by one and show you what kind of how you think through this. We'll have more ability to do this once we talk about second derivatives and concavity. But right now at this point, what we can know is we know about slopes, right? When we're talking about derivatives, we know about slope. We know where the original function is increasing and where it's decreasing. We know where it has a horizontal tangent line. So when I'm looking at this first one, I know it has a horizontal tangent line here and a horizontal tangent line here. So what I know about the derivative is it has a slope 0 at these two places. So it should cross through the derivative should, thanks Triggy. The derivative should cross through the x-axis at both of these places. All right. What else I know is, I don't know what this point is, but let's just say that this is -2, this is -1, this is 1, and this is 2. All right. I know that this is decreasing from -infinity to 1, and then again from 1 to infinity. So what I know about the derivative, the slope has to be negative, right? If it's decreasing, the slope is negative, which means it needs to be below the x-axis. All right, now it's increasing. It's increasing from -1 to 1. So it needs to be above the x-axis on this interval. So if I'm looking at this graph here, or I'm looking at these graphs here, the first thing I need is I need it to go through the x-axis at these 2 points. All right, so does it go through the x-axis at these 2 points? All right, so this one, it's going through the x-axis at these 2 points. All right, and I think that is the only one. All right, now it's below the x-axis here. So that means the original function is decreasing here in these 2 places, and the original function is increasing in this place. All right, so the correct graph must be this one. All right, so that matches to this one. All right, now B. B is pretty easy to find because of this. I know that these are straight lines, which means their slopes are constant. All right, I can't tell exactly what they are, but let's say that this slope is 1, right? This slope, it's increasing and it's 1. So it would be a constant above the x-axis. All right. Another thing I know is these places where they have these sharp little turns, they're not differentiable there. All right. So you're going to see holes in your graphs on the derivative. All right. They're not differentiable there. So you're going to see holes in your derivative graph. And notice that all of these are straight lines, which means the derivatives are all going to be horizontal lines because these have constant slopes, right? Like 3 or -5, all right? This is increasing. This is increasing. This is decreasing. So these two need to be above the x-axis. This one needs to be below the x-axis. And these two endpoints, they all need to have open holes because they're not differentiable at those points. All right, so this is this one right here, right? See, they have constant slopes, right? So that is 4. Maybe I'll do it this way. So this one was 2. This one was 4. Okay, let's take a look at C. All right, I do have a horizontal tangent line at 0. That means it needs to go through the x-axis at the origin. It's decreasing from -infinity to 0. Decreasing. And then it's increasing from 0 to infinity. So it needs to be above the x-axis here, below the x-axis here. All right, definitely this one here, right? It goes through the origin and it's above the x-axis after 0, below the x-axis before 0. All right, so this is 1. And then obviously 3 is D, but let's take a look at it. So I have a horizontal tangent line here, horizontal tangent line here. So it should go through the x-axis there. It is decreasing. It is decreasing, so it should be below the x-axis before that point. It should be below the x-axis again after this point, and increasing in between those 2 points. So it should be above the x-axis. Whoops, I'm looking at opposite. Flux, can you keep your hand off the? I'm looking at it opposite. All right. So I should have a horizontal tangent line here. I have a horizontal tangent line there. So it should cross the x-axis here and here. It is increasing from, let's call this point A, and let's call this point B. And it also has a horizontal tangent line here. So maybe let's call these A, B, and C. A, B, C. So it's increasing. Fluffs, do you need attention, buddy? All right. So I'm increasing. Thanks. I'm increasing from negative infinity to a. I'm also increasing from b to c. I'm decreasing from a to b. And I'm decreasing from c to infinity. All right, so that means I need to be above the x-axis from negative infinity to a and from b to c. And decreasing from, I need to be below the x-axis from a to b and from c to infinity. All right, so I should cross the x-axis in 3 places. So 1, 2, 3, and let's just label these again, A, B, and C. I should be above the x-axis between negative infinity and A, so there, and between B and C, so here and here, and D below the x-axis between A and B, and between C and infinity. So this is 3. All right, so I'm hoping this helps you on trying to figure out how to graph these derivatives. Maybe we'll try one where we do it ourselves. Let's take a look at, let's take a look at 4 and maybe let's take a look at 8. All right, so 4 is pretty similar to the one that we just did. We have horizontal tangent lines here, here, and here. All right, let's label again A, B, and C. One of them's at the origin. So here's A, B, C. Excuse me, folks. All right, so this one is decreasing from, come here, buddy. I need you to sit still for just one more minute. So decreasing from negative infinity to A and from B to C. And I'm increasing, you helping, from A to B and C to infinity. All right. All right, we're almost done, bud. We're so close. All right. So if I'm decreasing, that means I need to be below the x-axis. All right, so I'm below the x-axis from negative infinity to A. I need to be above the x-axis from A to B. I need to be below the x-axis from B to C, and I need to be above the x-axis from C to infinity. All right. Now on number 8, I will say that there needs to, that it is not differentiable at this point here because it has a little, I don't think it's really a point, I think it's more of a cusp, but anywhere there's like a sharp point or a cusp, it's not differentiable. Another place that it's not differentiable is when you have a vertical tangent line. That would be right here. And what we would do there, instead of putting a hole, because there's an entire line there, a tangent line, you would put in an asymptote. All right, so I would have an open circle here, and it's decreasing from negative infinity to that point. So it's going to be below the x-axis, and it's increasing after that point. So it's going to look something like that. All right, it's not a straight line. These aren't constants. So this is not going to be a constant slope. It's pretty close, but it's not. All right. So anyways, I hope those examples are helpful, and hopefully you had a good weekend and Leopard is not going to be patient anymore. So I'll talk to you guys soon.